My dear students, good morning all of you. Today topic is Newton's laws of motion, and we are going to discuss about Newton's second law and the impulse. So first of all, what is Newton's second law? It always states that the rate of change of linear momentum of a body is always directly proportional to the force acting on it, and it takes place in the direction of the applied force. That is, yeah, the rate of change of Newton's second law, the rate of change of linear momentum, the rate of change of linear momentum of a body is directly proportional to the rate of change of linear momentum of a body is directly proportional to the force acting on it. The force acting on it, and it takes place in the direction of applied force. And it takes place in the direction of the applied force. That is Newton's second law. The rate of change of linear momentum of a body is directly proportional to the force acting on it, and it takes place in the direction of the applied force. Then what is the significance of this Newton's second law? Significance. What is the significance of this Newton's second law? It gives the magnitude of force and the definition of unit force. It gives the magnitude of force, that is F is equals to ma, and the definition of unit force. It gives the magnitude of force. First law gives qualitative definition of force. Second law gives quantitative value of force. It gives the magnitude of force, that is F is equals to ma, and the definition of unit force. Then how we can derive this one? Then now come to the other one, derivation of. How you are going to get that one? Derivation of F is equals to m. That what is the derivation of this F is equal to ma when you consider this? First we have to assume, consider a body of mass small m is moving with an initial velocity u, traveling with uniform acceleration a, and attains a final velocity v in time t. due to the application of force F. To arrive the expression for F is equal to ma, first we have to assume that a body of mass small m is moving with an initial velocity u traveling with uniform acceleration a and attains or gains a final velocity v in time t due to the application of force F. Once you got the idea of this, then what is the initial momentum and what is the final momentum that we can calculate? First thing is initial momentum is given by Pi is equals to mass into initial velocity. That is mu. Similarly, final momentum, if you want, that final momentum Pf is equals to mass into final velocity. That is nothing but mv. But these changes takes place in a time t. Therefore, in t seconds, the change in momentum is mv minus m. Final momentum minus initial momentum, which is nothing but mv minus m. Therefore, in 1 second, the change in momentum is given by mv minus mu by t. This is what you can write. But this, the change in momentum in 1 second is called as rate of change of linear momentum. Therefore, now what you can write is the rate of change of linear momentum is nothing but mv minus mu by t. But here, from Newton's second law, force is proportional to rate of change of linear momentum. Rate of change of linear momentum. And once you got it, that F is proportional to mv minus mu by t, or F proportional to m into v minus u by t, or F proportional to ma, since acceleration a is equals to change in velocity by time. Therefore, F is equals to a proportionality constant k into m. Here k is called proportionality constant. So that is obtained as F is equal to kma, where k is called as the proportionality constant. But here we have to derive F is equal to ma. So if you are going to get F is equal to ma, means k should be equals to 1. Therefore, if we consider that is, you can consider that if m is equals to 1, a is equals to 1, f is equals to 1, then k is equals to 1. In that case only that f becomes ma. So here, when you made f is equals to 1, m is equals to 1, a is equal to 1, then only k is equal to 1. So when this F is equal to ma holds good only when you define the unit force. That is what you are going to get. First of all, we have to define here the unit force. What is this unit force? How can you define? That means the force required to produce a unit acceleration in a body of unit mass. The force required to produce a unit acceleration in a body of unit mass is called unit force. So whenever you define the unit force, then only that physical ME is holds good. And once you got the idea of this, what are the units for this one? For units of force, what are the units of force? First one is in CGS. It is given by how much it is? For mass it is in grams, centimeters, second minus 2, which implies it is expressed in time. And in SI system, it is expressed in kg meter, second minus 2, which is expressed in Newton. And we know that 1 Newton is equals to 10 power 5 dyne. This is about the significance of the Newton second law. It gives the magnitude of force, that is a physical ME, and also the definition of unit force. The force required to produce a unit acceleration in a body of unit mass is called as the unit force. Here in CGS it is expressed in dyne, and in SI system it is in Newton. You may be asked the question, how can you define 1 Newton? 1 Newton means the force required to produce an acceleration of 1 meter per second square in a body of mass 1 kg is called 1 Newton. Similarly, if you are asked to define 1 dyne, dyne means the force required to produce an acceleration of 1 centimeter per second square in a body of mass 1 gram is called as 1 dyne. This is about the Newton's second law and its significance. And once you got the idea of this, what type of questions, conceptual questions that may come from this simple physical ME? Let us say you will be given a concept 1. That means you may be given like this. 2 bodies of different masses. 2 bodies of different masses are subjected to the same force separately. So that the accelerations produced in them are A1 and A2 respectively. 2 bodies of different masses are subjected to the same force separately, so that the accelerations produced in them are A1 and A2 respectively. When they put together, and subjected to the same force, then find the acceleration of the system of bodies. Then find the acceleration of the system of bodies. Then for this what to do? It's very simple. That is, the answer for that is, let us say this is a body of mass m1 is moving with an acceleration a1. Suppose this moves with an acceleration a1 due to the application of force F. Then by definition F is equals to m1 a1, which implies m1 is equals to F by a1. Suppose this is the second body of mass m2 subjected to the same force, so that it's moving with an acceleration a2. Then F is equals to m2 a2, which implies m2 is given by F by a2. Now these two put together, this is m1 and this is m2, both are subjected to the same force, so the acceleration produced in it is a. Then F is equals to m1 plus m2 into a. Therefore, from this m1 plus m2 is equals to F by a. But what is m1? F by a1. What is m2? F by a2 is equals to F by a. Or F into 1 by a1 plus 1 by a2 is F by a. These two gets cancelled. Therefore 1 by a is equals to 1 by a1 plus 1 by a2, which implies a is equals to a1 a2 by a1 plus a2. That is about the concept. For any given numerical values of a1 and a2, we can calculate acceleration directly using the formula a is equal to a1 a2 by a1 plus a2. Next one. Now another one, concept 2, that what you can write is here. You may be given that two bodies of masses m1 and m2. Two bodies of masses m1 and m2 are initially at rest, or subjected to the same force separately. Two bodies of masses m1 and m2 are initially at rest, are subjected to the same force separately. Then find the ratio of times taken to have a bit same final velocity, same final momentum, C bit same displacement. This is the question you are given. Two bodies or masses M1 and M2 are initially at rest or subjected to the same force separately, then find the ratio of times taken to have same final velocity, to have same final momentum, and also to have the same distance. Because here we have to find all these quantities in terms of known quantities M1 and M2. Then what to do? Then for this, first thing what we have to do is force F is equals to M into A, that is nothing but M into V minus U by T. Or F is equals to M into V minus 0 by T, that is mv by d, since initial velocity is 0. Now what you are given is to have the first bit to have same final velocity. That is F is equals to mv by 2. When F and V are same or constant, m by t must be a constant, which implies t proportional to m. Therefore, t1 by t2 is equals to m1 by m. So, the ratio of the times taken to have the same final velocity is nothing but the ratio of their masses. Suppose you are given 2 kg and 3 kg, then ratio of times taken is 2:3. Directly you can get it. The second one is B bit to have same final momentum. In that case, we know that F is equals to mv by t, that is pf by t only. Mass into final velocity is the final momentum. Therefore, when F and pf are constant, then t must be a constant. If t is constant, the ratio of the times taken, t1 is to t is 1 is. So, whatever the masses, if the final velocities are same, the times taken will be the same. So, to have the same final momentum, ratio of times taken is same. To have the same final velocity, ratio of time taken is ratio of the masses. And third one is to have the same displacement. Third one is to have same displacement. To have the same displacement means F is equals to mv by t. This we can write this m by t into s by t. Since velocity is nothing but displacement by time. We know that one. Therefore, F is given by m into s by t square. When F and s are constant, then what happened? M by t square must be a constant, or t square is proportional to m, or t proportional to root m. Therefore, t1 by t2 is root over m1 by m2. So, to have the same final displacement, the ratio of times taken must be square root of the ratio of the masses. If you are given 2 kg and 3 kg, the ratio of times taken is root 2 is to root 3. This is another concept based on the simple formula F is equals to ME. And you may be given Come to the other one, that is another concept. A jet of water is coming out from a hose pipe. A jet of water is coming out from a hose pipe of area of cross section. Capital A. With a velocity v, strikes a wall normally and falls dead. Yeah, a jet of water is coming out from a hose pipe of area of cross section capital A with a velocity v, strikes a wall normal and falls dead. Falls dead means after striking the wall, the water will slides down. That means the final velocity becomes 0. That is the point we should remember. If rho is the density of water, then find the force exerted by the water on the wall. This is the thing. A jet of water is coming out from the hose pipe you are given. Then how to solve this? We know the basic formula is F is equal to ma. And here you don't have any such term. So here we know density, area of cross section, and velocity. So we have to convert that ma in terms of known quantities. How? That is given by here. This is the hose pipe. Water is coming out from this. This is the wall. It strikes the wall and then slides along the. This water is coming out with the velocity. This area of cross section is A. Let us say. Therefore, basic formula is known. Force F is equals to ma. That is nothing but mass into acceleration. That mass into acceleration can be written as volume into density, because we have to find out in terms of density and all. Therefore, acceleration, change in velocity by time. Again, this can be written as area into length into density. Volume can be written as area into length into density into velocity by time. Therefore, F can be written as in general area into length by time. Here I will take density into velocity. Therefore, area is area into velocity into density into velocity. Therefore, you can get that F is equals to area, capital A, velocity V, density rho, and this is V. Therefore, force exerted by the water is given by rho A V square. If you know the density, area and velocity, straight away you can calculate the force using the formula F is equals to rho A V square. Like that, there are so many concepts and model problems we can discuss based on this force. Thereafter, Now come to the other one. Another topic in this is impulse. What is meant by impulse? Impulse means when a large force is acting on a body in a short interval of time to produce a finite momentum. To finite change in momentum is called as the impulse. That is, what you can write is impulse means when a large force is acting on a body in a short interval of time when a large force is acting on a body in a short interval of time to produce a finite change in volume, change in momentum. Is called impulse. When a large force is acting on a body in a short interval of time to produce a finite value of change in momentum is called impulse. For example, if you consider this is the time and this is the force. When a large force is acting on the body in a short interval of time, during that small interval of time the force is very large, then we can say it is the impulse. And here it is measured as the product of force and time or change in momentum. It is denoted by capital I and is a vector quantity. So, when a large force is acting on a body in a short interval of time to produce a finite change in volume is called as impulse. It is measured as the product of force and the time or change in momentum. It is denoted by I, that I can be written as F into T or mv minus mu. This is about the change in momentum. Then what are the units we have? Units in CGS, dyne second. In CGS it is the dyne second, and in SI system, it is given by Newton second. In SI system it is given as Newton seconds. These are the points. This is Newton second is the value for that. This is about the impulse. But there are a lot of applications related to impulse. You may be asked different types of questions based on this impulse. Regarding that impulse, we can say that different examples. A cricket fielder, while catching a cricket ball, lower his hands. Why? It is simple. That is, whenever he catches the ball in a short interval of time, the impulsive force is more, so that the hands may get injured. Whenever you drag your hands in the direction of the motion of the ball, then the time of impulse will be increased. When the time of impulse is increased, impulsive force will decrease so that he can catch the ball safely. So different examples that what I can give is, example 1, a cricket fielder while catching the cricket ball lower his hands in the direction of motion of ball to increase the time of impulse. A cricket fielder while catching a cricket ball lower his hands in the direction of the motion of the ball to increase the time of impulse. As a result, impulsive force will decreases so that he can catch the ball safely. Generally, you may be asked, a cricket fielder while catching the ball lower his hands. Why? It is simple. A cricket fielder while catching the ball lower his hands to increase the time of impulse. When the time of impulse is increased, the impulsive force will decreases so that he can catch the ball safely. And also we can give some other examples related to this. You will be given that another example. It is easy to catch a tennis ball than cricket ball. It is easy to catch a tennis ball than a cricket ball. Why? You may be asked like that. Here what happened? What is the reason that we can write? Can you tell me here? What is the reason? It is simple. First thing is the mass of tennis ball is less than that of cricket ball. When both are projected, with the same velocity, then the change in momentum in tennis ball is less than that of cricket ball. So, the mass of tennis ball is less than that of the cricket ball. When both are projected with the same velocity, then the change in momentum in tennis ball is less than that of the cricket ball. Hence, momentum imparted on the hands by tennis ball is less than that of cricket ball while catching. That's the reason why it is easy to catch a tennis ball rather than cricket ball. This is another example we can give. And also we can give There are a lot many applications like this for the impulsive force. The third one is motor vehicles are provided with springs and shock absorbers. All the motor vehicles are provided with springs and shock absorbers to increase the time of impulse. Why? The reason is very simple. That is, whenever the vehicles move on an uneven road, if the vehicles are not provided with the springs and shock absorbers, then the shock will directly reach to the rider, so that he may get a back pain. But whenever it is provided springs and shock absorbers, then whenever it moves on the uneven road, the springs and shock absorbers gets elongated. Thereby, the time taken by the shock to reach the rider will be more, so that he can have a safe ride. And also like that, you can get that all a man jumps on the sand floor, cemented floor, receives more injuries than on the sand floor. A man jumps on the cemented floor, receives more injuries than on the sand floor due to the time of impulse is suppose a man jumps on the cemented floor. Then what happens? The moment he strikes the cemented floor, he will come to rest in a short interval of time. When the time of impulse is very small, the impulsive force is high, so that he will receive more injuries. But whereas if he jumps onto the sand floor, his legs will penetrate into the sand, thereby the time of impulse is increased, and hence the impulsive force is decreased, so that he receives less injury. So in both the cases, injuries are common, but the severity is different. Similarly, all the glassware are provided or wrapped with the piece of paper or a grass. Why? That is also due to increase the time of impulse. These are all several examples or applications of impulse. Okay? This is about Newton's second law and also impulse. Tomorrow we will discuss about the other concepts, that is types of forces and the contact forces and connected bodies. Okay? Thank you very much.